Well, okay.
All right, we are recording.
Welcome everyone to our Tuesday, October 8th dApp Developer Working Group session. Earlier today during the wallet session, we were trying to come up with ideas or thoughts or agenda ideas for this dApp Developer Working Group. So I'm going to throw out some ideas. I don't have an agenda really prepared, but I'll throw out some ideas, and kind of as a group we can decide in direction we want to go. So each week, Jim, Gary, and myself, we participate in a blockchain art session, and we're working towards developing a art on the blockchain project, which is essentially creating a distributed. Hey, Gary. I was so in the art on the blockchain project, we're working towards creating a distributed art object framework. So we're making progress on identifying what the framework is, but we're getting towards now needing to write down what the requirements are for creating a smart contract. So the thought was, before we actually sit down and start writing code, Rolang, it may be best to take a step-by-step approach to gather the requirements, and then once that requirements document is created, then go into writing the Rolang. The reason being, we don't exactly know what this art on the blockchain should look like. So, but if we have a requirements document, then we can go to perhaps like Eric Drayson, who's the expert. He created the distributed art object framework the background to it. Say, Eric, this is what we're coming up with. Does this look correct? Or perhaps go to Tomislav and say, this is the requirements. We're trying to build out this particular section. I think so. The thought was to have, if we have a document, we can more easily communicate what we're trying to do, as opposed to if we just go in to start creating code and having people look at code and mixed in with the comments. So that was the thought, and that was sort of an approach for today. But I'm going to kind of open it up as far as what others are interested in, and what else we might want to consider for this hour session. Any thoughts? Okay.
Yeah. So sorry, just finished.
Yeah, go ahead.
Finishing my lunch.
Sorry.
Something that came up in a meeting I had earlier today was we're going to need a way to prove the transaction speed of the blockchain. So it would be great if the dApp developer community could write some fairly simple, I think, Rolang contracts that could be run in a loop and just generate a boatload of transactions. I don't know how complicated we have to make it. Maybe it would be good to do a whole bunch of listening on channels and stuff like that, but we're going to need some smart contracts to do that. So it could be, I'm a dApp developer and I'm writing in JavaScript and I'm doing it from a web page, or maybe I'm a little more advanced and I'm running something from a Python script, or even from a bash script, directly against our node. But it'd be great if you guys could start thinking about some kind of library of scripts that would be used to stress test and be able to measure, in conditions, how many transactions we're actually getting.
Okay, bear with me here. I'm trying to take notes as well.
Maybe you should post the notes document.
Yeah. Okay. Yeah. Here, let me Bear with me here.
So I understand a lot of people of saying, well, you know, how many transactions per second are we going to be able to do? And I mean, we could take simple situations like Alice pays Bob and call that a transaction. And we could do 1,000 of those and a proposed, 1,000 of those and a proposed, 1,000 of those and a proposed. And we can see how long it takes to get finality. You know, of course, that would give us a base level to work with. And then we would need a more complicated mix of transactions.
Yeah. So, Jim, are you saying that you would? Oh, I'm sorry, my camera's off. Jim, are you saying that you would have the smart contract kind of batch them up in one deploy?
Well, that's the way that it's going to run, right? No, it's going to deploy each one separately.
Oh, okay. Okay. Cool.
And then it'll propose however many. Okay, we can try 1,000 and a propose, and we just repeat that and see how quickly the system processes them.
Yeah, but doesn't each propose?
You know, it's going to be.
Isn't each propose though atomic to the level of per transaction?
I'm sorry. Sorry.
Isn't each propose atomic? Like, you know, if I'm doing a transaction and you're doing a transaction, I'm assuming we're like my dApp and your dApp are just calling a smart contract. So that smart contract is going to do a propose every time it gets a request, right?
Probably not.
Oh.
What would you say, Rafael? You know, the way they were having it is that the node would periodically do a propose.
Yes, as I understand it, it will be arbitrary. The node, the validators will decide when they want to propose, maybe set some periodic operations, but I guess it's up to the validators to choose what is the delay.
So if I'm calling a smart contract that does like a payment transaction, you're saying built into that smart contract is some caching algorithm, so it's bunching them up and not.
No, you're doing deploys, okay, and and actually a deploy can be one transaction or it could be 100 or 1,000, and then you and other people are all going to be doing deploys,
right?
Okay, and none of these will go onto the blockchain until a node does a deploy.
The
and
propose.
It's going to then deploy all of the,
The propose, yeah.
All the transactions deployed are then going to be executed when it's proposed.
So it's not the smart contract that does the propose. They only do the deploy.
No. The user has no power over when a block is created and when it is accepted.
Okay, gotcha. Okay, that makes sense.
Finally, it's a bit like Bitcoin. With the Bitcoin network, during 10 minutes, you just air transactions to the nodes, and after 10 minutes, eventually they get included.
Gotcha. Okay, that makes sense. That's interesting. So, okay. So based on how often the validators are doing the deploys,
I guess we don't know for sure yet.
right?
But I guess it could be something like 30 seconds, but for testing purpose, it does not matter. We don't need to know what the delay will be with main network. We just want to test how fast it goes. So maybe we could just like Jim says, we do 1,000 deploys, then we propose, and then we run. Continuously some listen data name queries and wait for the right result to come up.
I see we have access to Testnet now in Rundeck.
We can deploy to Testnet?
We have Testnet. We have access to Testnet and Sandbox, and I guess we have to be careful how we use it. But if we look at the Sandbox or the Testnet, okay, we have I guess in the start, our node. I'm not sure where we had it. Basically, wait time in seconds to wait for approved block. Okay, well that's not it. Wasn't there something in here that would say how often we wanted to do a propose? I mean, we could run something here.
I don't know.
I think we should be able to do it, like a Bob Pays Atlas example, and just see how many of them we can do. And we can do them currently on Sandbox and Testnet. But okay, so this starts it off. So we don't, we look at jobs again. Dump DAG, dump data, dump info, control auto propose right here. Okay, so we can say that we're going to propose here every 60 seconds, right? And there's the where's the deploy? Oh, here's deploy. Okay, we can deploy contract to nodes. So we can replace this with the Bob Pays Atlas example. Or we can look at this shortfast.row and see how many transactions it does, if any. And we can try just example.
Can you set that in a loop, or are you going to have to just keep hitting the enter key?
Well, my understanding was that it would deploy the loop. Okay, obviously we could always create our own loop, but we would want to,
Yeah, you probably don't want to make it too easy for people to do a loop.
so arguments to deploy, that doesn't really help us. Run jobs later. What does that mean? Schedule job. Set start time. Okay, so this just runs it once. Not a million times, I guess. Okay, well, deploy show. Auto propose log. Show blocks. Last finalized block. Start node. Stop node. Okay, so it's easy enough for us to write our own deploy loop. All right, we could just do an R node deploy. See how many of them we could do. I don't know why I don't have this. So yeah. So yeah, so we could just do an R node deploy of let's say Dan pays Alice .row. And just do that in the loop as many times as we want. And then we let the network auto propose. And we see if we can propose more. If we can propose more transactions than the network can handle. Right.
And how would we be as far as reporting to be able to know how many transactions were processed per second? Do we have to create a report, or will a report be generated?
We would have to. I mean, we can keep track of how many we deploy. We don't know exactly how many we're going to get in each propose. Of course, we could do the propose manually too. So we could do exactly 1,000 and then do a propose.
Oh, okay. Yeah.
Okay, and I guess we would turn off the auto propose.
Okay.
And then it's just a question of, let's see, how do we look at the activity? Hello. No, it's not. What am I thinking of here? We want to look at the graphs. So we want to look at our node. I forget what we look at again. I guess if we look at the nodes here. And how do we look at the how do we look at the node again?
There's another website which shows the reporting for node activity.
Right, that's what I want to look at.
Yeah, it's
There's
I'd
no
have to
link to
get.
that here.
No, I don't believe so.
I could have sworn there was a link
Let me
that gave us.
see if I can get that here. Bear with me.
Why does the testnet result one node? I had 10 nodes a minute ago. And I got one node. That's weird. Maybe somebody just started it or something. Yeah, I had 10 nodes running. Now I have only one.
Now, one thing I remember, Nutzipper, he did create a script which executed multiple deploys and to determine which ones run and which ones fail. So that script is available.
Jim, you only got one node because there are in the search bar, there are tags. Just remove them all. In the search bar on the top.
I sort of missed that.
On the top of your screen, all the tags, just remove them and you will see the 10 nodes, if that's what you want.
On the top of my screen, look at the testnet. And here I see 10 nodes, right?
Yes.
But when I click on, now I see all 10.
Okay.
Okay, I guess I was filtering on it. I was only
Yes, when you click on one, it adds a filter.
Now, wasn't I able to get some information here somehow?
So I just put in the chat the link to collected RChain dev. So if you click on that link, you'll be able to get the reporting, the node reporting.
Yeah, I don't know. I keep forgetting how we do what here. If I haven't done it in a week.
Yeah.
I got too many other things going on. Where's the chat? I can find the chat. Let me stop the share. Then I'll put the share back again. Okay, yes. This is good stuff. Okay, so we look at a node here. Okay, and we can look at the protocols, our node, VLAN,
yeah, that's cool.
processes,
Cool stuff.
context switch, CPU, memory load. I'm missing. There was something here that showed this. We used to see the proposed delay on here.
So you're looking for the proposed delay, you said?
Yeah, the long proposed times.
Oh, that's a special
Another
tool.
report. There
Yeah.
was one in here. There was also one in here that showed the proposes.
Yeah, I thought that RAL had a special tool for that
Like
one.
this.
I'm not sure.
I'm just looking here because
Yeah. If we do have access to that report, it would certainly be in this suite.
okay. The interface traffic. It shows the traffic increasing linear. I'm not sure what test they were running here. But obviously, when we're doing some tests that linearly increases the traffic, and then all of a sudden, it doesn't get anything more done, then we have then we're hitting the maximum number of transactions. Well, I guess even if we look at the I guess even if we look at the CPU, I mean, this shows very steady CPU. So, do we have something like a Bob Pays Alice out of the box that we can use? And let me see, this here is
Well, here's.
I'm going to stick this somewhere. I'm going to stick it in node runners. No.
What about?
I'm going to put it in the main RChain.
Okay.
And I guess I don't know whether I should. We have the 3 channels here. I'm not sure which one to put it in. I'll put it in the sandbox. Probably can go in both places. And we should be able to pin, I think.
I believe so.
No, we can't.
I
I
can.
thought in developer we could pin now.
I thought.
Try it. Can you pin? Ian said in the developer section we should be able to pin. And that's really the only way we can find relevant information.
Yeah.
Is to pin it. Of course, we can all pin in the collab.
Well,
so you pin that. Okay. And I suppose we should pin Rundeck too.
no, that's just for administrators. That's for you, me, and NetZipper. They're not. No one's going to be able to log in.
Okay.
The login is for us 3.
All right.
What if we were to, when we talk about transactions, there's the 3, there's check balance, and there's 2 others that Sebastian created So if you want to check your balance of what your, what your rock is, what if we were to just check balance in a loop, over and over and over again 1,000 times? Would that constitute as, number of transactions per second? Just that query? Because
Well,
that,
I mean, one of the big fights we have is what we mean by a transaction, right?
COM event.
Yeah. So, well, that's
That's
one
how some people
definition.
look at it.
That's one definition.
Yeah.
So I'm looking.
I think some basic transaction would be some counter stuff. You just have a counter that starts at 0, and each deploys increments some number, and then so you deploy 1,000 times, and you check that the number is 1,000. This way, you are absolutely sure that the each transactions has been processed. That could be some form of, yeah.
But what is? But a lot of people will not. Will only think about transactions in terms of transferring money from one account to another account.
Okay. Yes, of course.
So I think it's important to, on the one hand, we have the equivalence of a COM event and a transaction.
So we could just deploy some Genesis balance. Bob has 1,000, Alice has 0, and each deploys. Bob pays 1 to Alice, and you do 1,000 deploy, and you monitor how much time it gets. This way, you have the equivalent of a monetary transaction in Erlang. I'm not very familiar with all the Rev related deploys.
Rafael, so say that deploy again. What would be the scenario?
So you have, for example, on the test network, you have two public addresses. One is Alice's, the other is Bob's. Bob's has 1,000 revs, and at each you deploy 1,000 transactions, and at each deploy, Bob gives 1 rev to Alice. So this way, you have 1,000 true monetary transactions. So it will be some fair monitoring, because you're not just incrementing a number on a channel. You're doing real rev exchange.
That seems to be that's a nice basic example. Perhaps use that as our base model, base transaction. So Bob has 1,000 rev, and he's going to transfer 1 rev 1,000 times, and we're just going to run that in a loop over and over again, and then once it's completed, then we have a report which indicates the time, how long it took for those 1,000 transactions to process. Now, and if it's quick, then 1,000 can become 5,000 transactions, or 5,000 rock, and then move it up to 10,000. So we just keep moving it up as needed.
That's right.
It's an understandable basic model. So I think that's a nice proof of concept a starting point, and we just I'm just trying to think how do we know, how will we report on where can we find how long it took to process those 1,000 transactions? Where would we, do we need to have a row IO standard out, or is that another? Yeah, I'm just not. I'm maybe if I sit here and think how we can generate that report.
I guess it will depend on is it some testing that targets the testnet or some local standalone node?
Well, I guess we can certainly do both scenarios.
Okay.
Do it locally, and then if once we feel, hey, we got it working, then run it to testnet. I tend to think that maybe a local, well, depending on hardware, and I don't think testnet's any special hardware. Maybe locally you're going to get a little bit quicker speed.
Yep.
I'm guessing, and then testnet may not be as quick, but I don't know that for a fact.
Some idea would be to do a periodic stuff instead of just a one row loop. For example, you start with one transaction every second. So every second you trigger a $1 transaction between Bob and Alice. And for example, every 30 seconds, you check that the balance is 1,000 minus 30. And then if at t plus 30 you check that the balance is 1,000 minus 30 and it is that number, it means that the test network can process one transaction a second.
Oh, okay.
You take this number up to 5. So each second you send 5 transactions.
Yeah, that's another way. So that's another way. Okay, that's clever thinking.
This way you can make sure that there is not a pile of transaction that has not been included in the blockchain.
Okay, so we're executing one transaction every second, right? So we're not getting any errors. So then we start increasing that number of transactions for each second. And then if we reach a point to where there's more transactions in that second that they can't be processed in time for the next execution to start, perhaps there's going to be an error generated. And that's how we'll know that we've reached that threshold.
Exactly. Okay. So you have some kind of checkpoints in the time where you check that the balance is the right balance. That would be cool to code.
Okay. Okay. Well, that would be kind of fun to work on, as far as, I understand that, and coming up with the Rolang. So perhaps we can code that up and have that as our Rolang and executed in. Did we determine if in Rundeck that if we load, so we call this transactions.row. So I guess there would be two. There would be the transactions part, and then would we want the check balance as part of that same deploy?
Yes, I don't know exactly how this check balance works. I have to look at it.
So there is check balance.row. And
I think we don't need a deploy to check the balance. That's, I'm not sure.
So
Do you have the link of the check balance file?
Yeah, hear me pull that up here. Bear with me. I just,
not sure what we're doing here. What I was looking at a couple of points. We're looking for something specific here.
so in the RChain repository, there is the check balance dot row, and Rafael wanted to look at that file. So it's
Okay.
there was 3 files that Sebastian created: transaction.row, check balance.row, and there's one other one.
Okay, so transaction.row.
Okay, I found it.
Oh, okay.
Yeah, we should put that in the link in the chat or in the channel. I put a couple of links in the channel. If you put that link in, that would be good. I just want to show we have this wallet contract here, which is the requirements. And, you know, in Agile methodology, okay, we create user stories to develop our requirements. And then we, in our work studies or whatever, in our sprints, we develop one user story at a time. You know, it's different from the old-fashioned development. I thought this, you know, the requirements for a wallet are going to be pretty much the requirements for any kind of transaction. And specifically, I'm looking at buying and selling the art object, the art object reserved rights. Okay, so executing the transfer and sale agreements here. But we have we'll have a set of user stories associated with that. And that was just a thought.
Okay.
Approach there.
Yeah, if you could copy. Oh, you put it in the was in the that was in Discord.
Yes, in Discord.
Um,
Another thing I have in here is the make mint.row.
what channel in Discord?
The blockchain art.
Okay.
Okay, and you know, and this could have easily gone for the transaction discussion that we're having as well. I mean, we can look at this mint here, and we can see how the you know, the deposits and spends are done here. And, you know, we could easily, I guess, update these procedures to do any number of deposits and spends. And then we could deploy this as a way of testing transaction speed. Now, my understanding was that to actually send money or whatever, did I put it in here? Or did I put it
No, I'm not seeing any of those links.
Okay, so I put them into the dApp developers group, which is where we are here. Okay, put them in today. Okay, so the wallet contract, this is the requirement. This is the Rev Vault. This is the mint. Okay, the Rev Vault is very similar. It's another contract which actually does the make mint. And I think the whole mechanism here of the is based on the Jesse design of Mark Miller for the capability-based access. But this is I forget what I was looking at here. But you could just basically make a vault here and you could do transactions. Like you do a Rev Vault transfer here. Okay, and you have Rev amount, whatever. Okay, so we can put in here as many different transfers as we want. So I mean, we could make it.
Because this role encode that we are looking right now is the Genesis vote. When someone has no address, he deploys that.
Well, you know, this code is obviously not current. I don't think. Let me see. It looked like it was using. No, I guess it could be current. Never mind. Point is that, you know, we have code that does. This was updated 7 days ago, so this is pretty current. We have stuff that does transactions. That's all I'm saying. So we could always modify it to do more transactions, and we can deploy it in a loop if we want to have it done many times. So
Okay.
that was just so that was current. This make mint, I think, is older. Yeah, this is from June of 2018. And look, and this is using some public names, which is not kosher. I guess if it only uses that one public name, it's okay. Anyway. He's using that to call a library function. I don't know. But that's, yeah.
Okay.
Those, you know, I was just looking for some. I did not find the examples that Dan did or other simple Bob Pays Alice examples already out of the box. You've got a number of demos of Bob Pays Alice.
Well, let me ask this question to Rafael. So with that example you gave earlier, where Alice pays Bob 1 rev per second, and he has 1,000 revs, and that's executed, how is it? Would you be able to code that up in Rolang? Is that here? Let's see here.
You're on mute, Rafael.
Is he on? Is he talking?
You're talking on mute.
There we
Yep.
go.
Yep. I could set. I just switched to Arnaud 9.5, but after it's done, I can work on some basic demo to start with, and like some counter incrementation, and just after that, I'll switch to some revs transfer, just like we said. Maybe I'll be able to present it pretty soon, because I think it will be quite simple to code some basic operations.
Okay. Yeah, it's
so
yeah.
At the moment, I'm only working with my local standalone node. So I'll test it and see on my machine how much transactions I can get through.
Okay.
And after that, I'll do a GitHub repo where anyone can just run the same thing on some other network.
So, well, that would be interesting, you know, as far as kind of the progression. So after you get done with your current work and you have a chance to create the Bob Pays Alice transactions, and I called it transaction.row. I don't think that's really a good name for the file, because I think that's already used. Whether you call it bob.row or, and I'm the world's worst at trying to come up with a name for a file. So I'm sure you'll come up with something that's descriptive. But if you come up with something simple, run it there locally on your computer, and then then after you run it, so in the developer channel, just say, just have an update. I'm running bob.row, 1 transaction per second, and this is what's happening, and then you're increasing, and then it'd be interesting to see as you increase it at what point it fails. So, but I think you, of anybody here on the call, you got the kind of the best handle on how the approach on how to get to what it is we're trying to get to, which is determining how many transactions per second we can run. So I mean your idea was right on the target. So
great.
Yeah.
I think the issue will be to determine what the bottleneck is, because maybe the bottleneck will be the gRPC API and not the virtual machine itself. So I guess we'll see all that later, but it might be the gRPC API or the node process that I will run, but I doubt it. So let's do it, and we'll see.
Okay. Well, that's another aspect of it that I hadn't really thought about it, and that leads me to think about all the conversations with Tomislav. So me make sure I understood what you just said. So there's a way that you can run those deploys without using the gRPC. There's an alternative.
No, I don't know about that, but yes, maybe it will be the gRPC API that is kind of the bottleneck.
The bottleneck, right?
Even if the virtual machine can process a lot more transactions, But
Okay.
that's just ideas I'm throwing.
Oh,
in the
okay.
con-
Yeah, I think that's really great because that'll be helpful because I think using that API is how most of the outside world is going to interact with RChain. And then it would be helpful to take those smart contracts and then execute them directly, from a node, in like a bash script, just run some, batch files from a node, not even going through the gRPC. And actually that would be really helpful, right? Because then we'll have a differential and be able to tell people,
Yeah.
you use the gRPC, you could expect this, but if you want to go directly, you could expect this.
Yeah, well, if you do an R
And
node
of
deploy,
course, there is.
if you do an R node deploy, it's still doing gRPC in the background. You're not doing it, but it's doing it.
I did not know it.
Is that true? If I spin up my own R node and connect as a, but I'm
When you do an R node deploy, it runs a client. Okay.
unless I'm a validator.
It doesn't matter whether you're a validator or whatever. You're only running a client when you do an R node deploy. You're not running a node. The node's already running or not locally. You could be deploying to any node anywhere. And it's running a client that connects to the gRPC node that could be running anywhere. Default is it's localhost.
Okay.
But it's doing gRPC to do the deploy.
Interesting.
As a
Okay.
client.
Remember that guy, Jack Mills? He worked for us he was really from Hierophix. And they had hired him as he was really technical. They'd hired him as a documentation specialist, but he had actually been one of the original people over at Intel. Do you remember him? Because he was looking at an alternative to gRPC, and I can't remember what it was called. Anybody remember that?
Nope.
Yeah, it was before my time.
It wasn't that long ago. But yeah.
What was his name?
Jack Mills.
Jack Mills. No, that name doesn't ring a bell.
I guess he was let go like in September, October. He was like one of the first, because he was like the last one in. So he was one of the first ones.
Yeah.
But he had some really interesting ideas on performance. And
Interesting.
he had this alternative to gRPC. Yeah, but I can't remember. I don't think he ever delivered. He was writing a paper on it. I don't think he ever finished.
Okay.
I don't know. We used
Okay, so
ASN1 back in the 80s. I don't know why they aren't still using that.
I mean, why do we have to use anything except for assembler? That's all we need.
Right. The whether it's ASN1 or gRPC, it's just a matter of keeping the type information and the data and the most efficient bitwise way you can.
I mean, writing to the registers on the chip is always the best.
Yeah.
All right, guys. Hey, this is really great. I really appreciate the effort into drilling down into this. I don't know if we could actually do anything effective at this point, or we have to wait, for Testnet to be, a little more.
Rafael, can you give us a transaction to run? I mean, I was looking at these other things. We could probably figure out some transaction to run, but the best we can tell people is that the code that we have now does maybe in order to do a payment, maybe does 5 or 10 COM events.
I think we may want to wait because it may not be a realistic number depending on where we're going. if the number is too low, people are going to get discouraged.
Well, it comes back to, you know, the interpretation of a common event as a transaction. And theoretically, it is. But if we're going to actually send some money, we're going to need more than one common event to do it. And this is what people fight about. How many transactions? Well, you know, it's really how many common events, theoretically.
I've capitulated to Greg's definition as a common event for now. But once we go out and we start talking to business people, they're going to want to know, how long is it going to take me to send them from Bob to Alice?
Right, exactly.
Not how many common events it took. So, you know, we're still in the lab. That's fine. We can deal with common events. Eventually, we're going to have to come into the light of day. And but we could have that discussion later.
The thing is, you know, when you have a blockchain like, you know, that's made to do a transaction, you know, that's a meaningful figure. Bob pays Alice. But when you have a blockchain that can do anything, and you're saying, well, you know, maybe you take 4 or 10 to pay Alice, but you don't need to take that many. You can take 2 or 3, and you can do a lot of other things. You know what I mean? You can have transactions that use less, whereas in a blockchain that is designed to do Bob pays Alice, that's the minimum. That's what it's going to cost you no matter what you do.
Right. And remember, we're still at 1.0. I'm sure as the platform matures, people are going to find, as they always do, ways to squeeze out, I don't know, let me just say it this way, every last common event to make them like super efficient, right? So. Well,
it's amazing when you think of the power that you have with a single common event.
Yeah.
I mean, it's like you can have all this guarded things. When you have this state of the universe, I want this to happen.
Yeah.
And
you guys have another meeting now? I see people joining.
Yes.
Okay.
This is we're entering the collab work study. So
I mean, I see Daryl here, so it must be my time to leave.
So we're doing but I guess you guys have another meeting, right?
Yeah, I've been kind of going for a long time. I got to take a my brain is a little mushy. But hey, I mean, I really appreciate you guys jumping on this whole thing, and it's encouraging and it's looking really good. So thank you.
Yeah.
And I'll talk to you guys tomorrow.
All right. Take it easy, Ned.
See you later, Ned.
All right. I guess I'm gonna restart the recording here.
Yeah.
We're going into different phases.
Okay, so